Hello, I am Jackson Shibley. This is the Interim Design Report for Spacecraft Design 2. This project focuses on the exploration of Europa. Europa is one of Jupiter's moons with a global subsurface ocean beneath its ice shell. The mission is to measure the thickness and structure of the ice layers to support drilling and submersible deployment. This is to be done by using my project, a ground-penetrating radar. The apparatus consists of a rolling cart with transmit and receive antennas positioned on the front and rear respectively. The transmit antenna will send out a pulse, which propagates through the ice, eventually being reflected back. The time delay between send and receive pulses informs us of the depth of reflection. Meanwhile, the frequency that is reflected informs us of the composition of what is reflected by. There's a camshaft attached to the wheel, which will fire a pulse twice per revolution of wheel. These pulses are stitched together to form a two-dimensional map of what is below the ground-penetrating radar. Here's how it works. A microprocessor sends a signal to a digital-to-analog converter, which then output a varying 0 to 5 volt signal. This is boosted to a varying 0 to 12 volt signal using a buck converter in combination with an op-amp. This signal is then input into a voltage-controlled oscillator, which then varies between 400 and 850 MHz directly proportional to its voltage input. The signal is then amplified using a power amplifier and sent out the transmitting antenna. The receiving antenna position below it first enters a low-noise amplifier before entering the mixer. After that, the intermediate frequency amplifier amplifies the desired frequencies. And then, the low-pass filter filters out any unwanted high-frequency noise or noise from the radio frequency board before being digitized by a 14-bit analog-to-digital controller. I've completed all necessary circuitry for this project and chosen printed circuit boards due to the fact that RF components only come in tiny surface mount packages. This also allows me to use RF shielding built into the circuit boards. I've split the boards into two sections, the radio frequency board and the low frequency board. The radio frequency board goes on top, then a copper sheet and low frequency board. This ensures separation of signals between the two boards. I've also completed my antenna design, which is an antipodal Vivaldi antenna. The Vivaldi antenna has a wideband nature and is also incredibly easy to manufacture using PCB techniques, hence why I chose it. Moving forward, I wish to achieve the software development and apparatus development by the specified dates as you can see on the screen. Please note that the attachment of peripherals to the cart and final assembly may be delayed due to manufacturer's shipping time. Thank you.